This is the beginning of a two-part lesson on Chapter 9, Section 2, looking at the characteristics of a quadratic function. So let's take a look at what some of our directions will look like on tonight's homework. First one says find the zeros of each quadratic function from its graph. Well, we better figure out what are these zeros. So basically a zero is when we set y equal to 0. It's the x values when y, or the function, equals 0. So what we're looking at here, this graph, which we call a parabola, is formed by some sort of function. And the general equation of the function, remember we've talked about before, goes this way. It goes y equals, and then we have the ax squared, where a stands for some coefficient of the x squared term, plus, and then, or it could be a minus, bx, and a could also be plus or minus as well. And then b again is a coefficient of the x term, and then the plus or minus the c term. So the c term is just the constant, doesn't have a value of x. Now, what we're doing here is we're going to set y equal to 0, and then we want to come up with what are the values of x when y equals 0. So again, we're putting 0 in place of y, and we need to figure out what is x. So what is x? And so all you really have to do on these problems is look at the y-axis. Here it is. Well, when y is 0, that means I'm on this axis right here. I'm along this x-axis. So we're looking at where does this graph cross this x-axis. And where it crosses the x-axis is the values that we're looking for. And so here it crosses this point at -6. So one of the x values is -6. The other x value, if I come over here, it's right here at -1. So those are the two x components, two x values, well, when y equals 0. And those are called zeros. And they have some other names. So we can call these values here zeros. They also sometimes refer to them as roots. And we also have solutions. So when you want to solve the quadratic, that's what we're looking at. So various names that we can use to represent the same thing. Well, again, we've got another example here. So we could have two answers for this one because it crossed the x-axis at two different values. And over here, when y equals 0, so when y is 0, we're along this x-axis here again. You're looking for where does it cross this x-axis? Where does this parabola cross it? Well, it doesn't. It does not cross. Does not cross the x-axis. And so if it doesn't cross the x-axis, that means that we have no solution. So there's a few different ways you can write it. You could either write no solution, or you could even maybe put like a 0 with a slash through it. That represents no solution as well. Or there's another way. We could represent it as the empty set. This is the empty set. And so it just means there's no set of solutions. And so again, we're looking for finding those zeros. Where does it cross the x-axis? Oh, it crosses right here. At this point, this is where y is 0. See, y is 0 at this point, and that's what we're looking for. That's why they call them zeros. And so it's at 0 at 5. So there's only one solution here. So the only x value is 5. Sometimes they put the answer inside some braces to represent a solution set. So I'll do that for you in this instance here. Or you could just say x equals 5. So we have three different types of solutions. We either have one with two possible answers, like we have here, one with no solutions, where the graph just never does cross the x-axis, or we just have one solution. So you might see that on tonight's homework. The next set of directions directly below that asks us to find the axis of symmetry for each parabola. And so what we're looking at is when we see these parabolas, we have what's called an axis of symmetry. It means that we could cut this into two equal pieces. So let's say somebody was standing right here and somebody was standing right here, and they were swinging this rope And think of this like a jump rope, and they're swinging it. And where would the maximum point end up being? Well, the maximum point looks like it's right about here. Well, if I cut this parabola right down that maximum point, so I go ahead and just draw a dashed line here, represent like a cut. I cut this parabola into two equal pieces. Notice that it's equal on both sides. And so this is what we call the axis of symmetry. So the axis of symmetry is a vertical line. And so this is just a vertical line. And whenever you have a vertical line, you've got an equation that just has x. There's no y component involved. And so, because y could be any number. And so it's just going to be whatever it crosses, wherever it crosses the x-axis, because all the x values are going to be the same. Y values would always be, could be any number. So notice that if I plug in a point, like this point right here, the y value could be any number along this line, no matter where I put my dot. But I want a specific dot. I want where it crosses right at the top there, and that would be the maximum point. Well, the x value of that maximum point looks to be right in between 3 and 4. See, here's 2, here's 3 right here, here's 4 here. So we would say x equals 3.5, or 3 5/10. So that would be the axis of symmetry. It's just the number right in between, in this case, those two values. Well, let's take a look at the next one. Again, all you're looking for is where could I draw that line in which it would cut this parabola into two equal halves. Well, all you have to do is look for that maximum, or in this case, minimum point, which is right here. And then if I draw that dashed line right here, like I'm cutting this piece of paper right down the center, I have two equal halves of this parabola. And so what is this vertical line? Well, the vertical line, since there's only one x value and an infinite number of y values, it's just x equals wherever it crosses the x-axis, which is in this case at 3, right in between 2 and 4. So there's our answer. So the axis of symmetry is x equals 3. Over here we do the same sort of thing. We look for where the maximum point is, because if we draw a vertical line right down that maximum point or minimum point, depending on the type of parabola, that will cut this parabola into two equal halves. And so here our minimum point, or maximum point in this case, is above the x-axis, looks like one space above, and one space to the left. So the x value is -1. So that is our axis of symmetry. Well, we'll be looking at some other sets of directions in part 2.